Dear students, do you want to get into the fascinating world of physics? Please see this video and also subscribe to this channel.
Dear students, in this video we are going to study about the types of spectrum, emission and absorption spectrum, and also about Fraunhofer lines. Dear students, now we are going to study about the types of spectrum, emission and absorption spectrum, and also about Fraunhofer lines. How we get the emission and absorption spectrum? Before that, we will see about the electromagnetic radiation from the objects. When an object burns, it emits radiation. That is, it emits electromagnetic radiation which depends on the temperature of the body. If the object becomes hot, it glows in red color. And if the temperature of the object is further increased, then it glows in reddish orange color and becomes white when it is hottest. So the spectrum in figure 5.11 here usually is called a black body spectrum. So this is the black body spectrum, and here the wavelength is ranging from ultraviolet, visible, and then infrared. Here the surface of the sun has a temperature of 6000 Kelvin. Carbon arc lamp has about 4000 Kelvin, and a lamp filament will be about 3000 Kelvin. So the temperature of the surface of the sun is maximum here, and 4000 Kelvin, that is the temperature of the carbon arc lamp, and here this is the temperature of the lamp filament, which is about 3000 Kelvin. Therefore, these two temperatures will be emitting the radiations in the infrared region, whereas the temperature of the surface of the sun will be about 6000 Kelvin, and that will be in the visible region of the spectrum. And this spectrum is called as a black body radiation spectrum. And this gives the graph between wavelength and the intensity of the radiation. Now it is a continuous frequency or wavelength curve depending on the body's temperature. Suppose we allow a beam of white light to pass through a prism like this. It will be split into its 7 constituent colors, which can be viewed on the screen as a continuous spectrum, as shown here. This phenomenon is known as dispersion of light, which you would have studied in your lower classes. And the different pattern of colors obtained on the screen after dispersion is called as a spectrum. It is nothing but a spectrum of colors. The spectra can be broadly classified into two categories, namely emission spectra and absorption spectra. In the first case, let us study about the emission spectra. When the spectrum of self-luminous source is taken, we get emission spectrum, and each source has its own characteristic emission spectrum. This emission spectrum can be divided into three types, namely continuous emission spectrum, line emission spectrum, and band emission spectrum. Now first let us consider about continuous emission spectrum, which is otherwise called as a continuous spectrum. If the light from incandescent lamp, such as a filament bulb, is allowed to pass through a prism, which is the simplest spectroscope, it splits up into 7 colors. Thus it consists of wavelengths containing all the visible colors ranging from violet to red. The examples are the spectrum obtained from carbon arc and incandescent solids. So here is a continuous emission spectrum. So an incandescent lamp is shown here, and light from it passes through a prism, and we get a continuous spectrum of colors like this. Next one is line emission spectrum, otherwise called as line spectrum, and that is obtained when light from hot gas is allowed to pass through a prism. We will get a line spectrum. That is given by here. So hot gas, light from that will be passed through a prism, and we get a line spectrum which will have different colors shown as a line like this: red, yellow, green, blue, like this. So the line spectra are also known as discontinuous spectra, and the line spectra consists of sharp lines of definite wavelengths or frequencies, and such spectra arise due to excited atoms of elements. These lines are characteristics of the element and are different for different elements. Examples: spectra of atomic hydrogen, helium, etc. Then we will consider about a band emission spectrum or band spectra. This band spectrum consists of several number of very closely spaced spectral lines which overlap together, forming specific bands which are separated by dark spaces. This spectrum has a sharp edge at one end and fades out at the other end. Such spectra arise when the molecules are excited. Band spectrum is characteristic of the molecule, and hence the structure of the molecules can be studied using that band spectra. The examples of this are spectra of ammonia gas and the discharge tube, etc. Next, we will study about the absorption spectra. When light is allowed to pass through a medium or an absorbing substance, then the spectrum obtained is known as an absorption spectrum. So this is what you should write for the question: what is an absorption spectrum? It is a characteristic of absorbing substance, and absorption spectrum is classified into three types as before. And first one is a continuous absorption spectrum. When we pass white light through a blue glass plate, it absorbs all the colors except blue and gives continuous absorption spectrum. This would have observed. And next one is a line absorption spectrum. Now light from the incandescent lamp is passed through cold gas, that is a medium. Then the spectrum obtained through the dispersion due to prism is line absorption spectrum, and that is shown here. Line absorption spectrum. Similarly, if the light from the carbon arc is made to pass through a sodium apple lamp, a continuous spectrum of carbon arc with two dark lines in the yellow region are obtained, as we get two yellow lines for the sodium apple lamp. Then we study about the band absorption spectrum, how we get this band absorption spectrum. When white light is passed through the iodine vapor, dark bands on continuous bright background is obtained. And this type of band is also obtained when white light is passed through diluted solution of blood or chlorophyll, or through certain solutions of organic and inorganic compounds. Next, we will study about Fraunhofer lines. What are Fraunhofer lines? That is, the Fraunhofer lines observed in the solar spectrum. The dark lines are observed in the case of a solar spectrum. How do we get this? When the spectrum obtained from the sun is examined, it consists of a large number of dark lines, which are called as line absorption spectrum. These dark lines in the solar spectrum are known as Fraunhofer lines. So you should write this. What are Fraunhofer lines? And that is shown here in this visible spectrum, ranging from 4000 angstrom to 7500 angstrom. Here the lowest wavelength is for blue color and the longest wavelength is for red color. So shortest wavelength for blue and longest wavelength for red. The absorption spectra for various materials are compared with the Fraunhofer lines in solar spectrum, which helps in identifying elements present in the sun's atmosphere.